Hey class, this is the last part for decomposition notes. So let's pick it up right here at chlorates. What are chlorates? Chlorates are anything, there we go, anything that ends in a ClO3, that's a chlorate. So when you see a chlorate, that means that you have a chlorate decomposition. Now the chlorate decomposition, there's the chlorate, always decomposes to form one thing. That's, well, to form, like, to decompose in one way, to form the metal chloride and oxygen. Okay, so let's take a look at what the metal chloride. The metal is always the first part, so K has a +1, Cl has a -1 because that's what the chloride is, and then plus O2. Remember, oxygen is always Brinkelhoff. So notice that when I go to crisscross these here, and I hope crisscross is like becoming natural for you, for like just something you just automatically do. That's what I'm hoping. So once I have that crisscrossed and I have KCl as my metal chloride, then I go back through and balance the equation. Notice I have 1K, 1K, 1Cl, 1Cl, and because there's no chlorate on the right-hand side, we have to break it up into 1 Cl and 3 oxygens. And I have 3 here, but I have a 2 here. So I do the same thing I've done always when I have a 2 and a 3 for oxygen on either side, is I put the 3 in front to get a total of 6, and I put a 2 in front to get a total of 6 here. So now I have 6 on both sides. Now I also have 2 potassiums and 2 chlorines, so I need a 2 here to get 2 potassiums and 2 chlorines. And now I'm balanced with a 2, and a 3. So what does it look like when it's not an easy chlorate problem? Well, let's take a look at calcium chlorate. Calcium chlorate that decomposes, still decomposes to form the metal chloride. The metal in this case is calcium, and calcium has a +2. You can look to see that the +2 is there on the periodic table of ions. And then, of course, we're still dealing with chlorides, which are always a -1. Now I get to crisscross and actually put a 2 down here to get calcium chloride is CaCl2. And then that's still plus oxygen, so that's still O2, like that. Now, notice that I have parentheses, and I have a 2 on the outside. So I have 1 Ca and 1 Ca, so that doesn't change. But now I have 2 times 1 is 2 Cls, and I have 2 here, and I have 2 here, so that works. 2 times 3, though, gives me 6 oxygens, but over here I only have 2. So if I put a 3 in front, that's an awful 3. Let me pull that down, get rid of that. I put a 3 in front there, it's still awful. That wasn't me that time, that's the board. 3 times 2 is 6, which gives me a total of the same number on both sides. So 1, 1, 3 would be how I balance that. Now let's move to oxides. So oxides. The oxides of metals 23 through 28 in the activity series can be decomposed into the metal and oxygen. Now I'm sure you're asking yourself, what is the activity series? Well, the activity series is a list of metals from the most reactive to the least reactive. And metals 23 through 28 are the least reactive. And here's that list, so you can see it. So this is the activity series, and it's on the equation test sheet that I have linked or attached to this assignment. So I would pull that sheet up. You see decomposition rules, and at the bottom it says this, activity series of metals. So what we're talking about is we're talking about 23 through 28 are these metals that are non-reactive enough to break away from oxygen. So these are the only ones that decompose with oxides. Okay, the rest of them would be, all the rest of these would be a no reaction. Okay, no matter whether it were copper up to lithium. Okay, so let's go back, see what we got. So the oxides of metals 23 through 28 in the activity series can be decomposed into the metal and oxygen. Well, as it turns out, let's take a look here. Mercury 2 is 26 and mercury 1 is 23, and because both of them are on that list, I don't have to worry about which mercury it is. I know it decomposes. So that's going to decompose and break up into mercury metal, like this. No, this is not Brinkelhoff, so you don't need the 2, and oxygen, and that is Brinkelhoff, and it does need the 2. But because it has a 2 here, that means I need 2 over here, that we put a 2 in front like that, and then I need a 2 for that mercury. Okay, now this one is aluminum If you remember, aluminum is not from 23 to 28, it's number 8, so it's actually fairly reactive, which means that this is a no reaction. And that's how you do that. Please submit the notes for this to this assignment. This is the only case where I'm asking you to submit the notes because the notes are so long. So submit the notes, and then tomorrow I'll do some examples and show you how to do when you put all of these decomposition reactions together. I'll show you what it looks like with examples.